Can you open the BlueJ?
Okay, sure. So I'll open up BlueJ real quick right now. Did you want me to make a class for it?
Sure.
Okay.
Can you create a for loop, a sample for loop, and a sample while loop?
Okay, a simple for loop and a simple while loop. All right, sure. So I'll full screen this so everybody can see it. So, well, I need to put in void main string args here and code here. Okay, so I'll start with a while loop. So what, do you want this while loop to do anything, or do you want me to leave it empty?
Let's start with a for loop first.
Okay, for loop. And do you want this for loop to, what do you want this for loop to do? You want it to go over a string?
Let's loop 5 times.
Okay, 5 times. Okay, sure. So equals 0. So the one thing I do with for loops is I always start off with int I equals 0, and then I say I is less than however many times I want to increment it. So in this case, it's 5, right? Then I say I is less than 5, then I plus plus. So I mean that pretty much nails the coffin every time I go for loops. Other people like to use equals. For me, it's kind of weird to do it this way, where it's like equals 5 minus 1, but I like to just use less than 5, and it's easier for me that way, because I could just say 5 rather than 6 minus 1.
And in this case, it counts 5 times because you start from 0. So 0, 1, 2, 3, 4. So if you count it with your finger, there is actually 5 times. The other way that you can write, if you don't want to start at 0, is start I equal to 1, and then your condition will be I less than or equal to 5. So that will be 1, 2, 3, 4, 5 inclusive. So either way, it will be the same.
So just to make sure this is actually working, I'm going to go ahead and print this out. So yeah, there's 5 elements here, 0, 1, 2, 3, 4. But let's say I wanted to actually print it all the way up to 5, then I would have to put it at 6 and make it start at 1, right? So if I didn't want to go over it by index, then I would have to increment both of them up by 1. And well, okay, well I have to clear out the first one, but these are the ones that I'm looking at. So it's 1, 2, 3, 4, 5. So it does work, and I should be clearing it actually. Okay, clear scan method call. Okay, there you go. All right.
And guys, so for for loop right now that we're using, they have 3 statements within this for loop. So remember that first for loop, the first statement always gonna be the initializing part. So where do you want to start? In this case, 0. And then the second part is condition. So what is the condition for it to stop? And then the last one would be, do you want to increment or do you want to decrement? So in this case, we want to print 0, 1, 2, 3, 4. Then in order for this condition to stop, we want to increment, because if we decrement in this case, it will go from I equals 0, I minus 1, and I equal minus 2. And so this loop will always be true, and that is going to be infinite loop, and that is not what we want. And so in this case, we want to increment.
Yeah. So the way I like to look at it is like how I laid it out in this inline documentation, the other known as the comments. So I look at it like for loops, the starting statement would be over here. So in this case, it was start at 0. And then over here is the ending statement, which is I is greater than 5, right? Or when I turns into 5 or more. And then there's the next step statement, which is like I plus plus, I minus minus, or you can even, if you really want it to be really hacky, you can say something like I equals, or like plus equals 2. That would actually, I think that would compile. Yeah, it does. But normally people just use I plus plus and I minus minus. But yeah, these are basically however you want them to be, as long as the only requirement is that this one is a Boolean, this one is returns a Boolean. Well, actually, wait, sorry. No, this one initializes your number. This one returns a Boolean, and then this one increments the number that you've started over here. So that's usually what the case is. And as long as it fills those requirements, it actually compiles just fine. So that's all you need to remember. And of course, whatever's the body of your code over here, in this case, it's printing. It's just going to execute that line over and over and over. So that's one way to look at the for loop logically. I just look at the start, the ending, and next.
All right. And since for loop we know wants to end, we can explicitly say 5 in the condition part. And since since this case we know when to end, we use for loop. But remember that for loop can be converted into a while loop. So let's look at a while loop.
Okay. So I'm going to pretty much do the same thing that I'm doing this for loop right now, but turn it into a while loop. So in a while loop, we don't really put this inside the while loop, but we actually put this statement outside of it. So let's say I wanted to say int I equals 0. So why is it we want to do this before the while loop, Yen? Why would you?
Because while loop starts with a condition, and in this condition we need a starting value, and we cannot do it inside the condition part, so we have to initialize I outside with a value first.
So I have to say int I equals 0. Then I have to say over here I is less than 5, and then whatever I want to execute, which is in this case, it's printing it. And then over here I have to say I plus plus at the end. So is there a reason why I have to say I plus plus over here again?
So for while loop, you always want to, the last statement would be the increment or decrement. Because if you don't do that, the value of I in your condition statement will never be updated. And also you want it to be in the last line because you want other stuff in between to finish, like calculations or printing out a value first. Then the last thing would be updating the value and go back to the condition to check if the condition is still true. In this case, when you first enter 0 less than 5, yes, you print I is 0 in this case, and then you increment to I plus plus. So also, in this case, you want I to be updated as a larger value for each time, not getting smaller. If you do smaller, it will go as an infinite loop. Again, would like for loop if you do I minus minus.
Okay, so if I compile this and print it out, they would produce the same thing, right? So
yes.
let's try it out. Okay, so when I execute it, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Perfect. Okay. So whoops, I accidentally closed it. Let me open it up again. Blue Jay. Okay. I have a bad habit of closing the entire thing. Okay. So let's go back to this. Okay. So some students like to put this line somewhere in the middle code, like this. Is that a good idea, Yen? Would you think that's a good thing to do?
In this case, no. So let's trace it. So if you have in the beginning you have 0, right? 0
Yeah.
go into here, 0 less than 5, yes. Then you increment 1. So now your I will be 1. So when you print, it will be 1 instead of 0.
Yeah, so...
And then again, you go up here, 1 less than 5, yes. And then I++, now is 2. So if you keep going until the end, it will print only 4 values instead of 5.
Yeah. So what's going to be happening is exactly as she says, where you count first, and then you make the number go up, and then you print it, and that puts it off of sync. This one, it prints it, and then it counts up, which is exactly what you would want. So if I try this out, they should produce 2 different things, like over here. So over here, it goes from 0, 1, 2, 3, 4, 1, 2, 3, 4, 5. Oh my gosh, I closed it again. See, I'm telling you, this drives me crazy. Okay, so J. Okay. Yeah. All right. So yes, exactly as we thought. It should be over here. So that's basically how a while loop and a for loop can look like. So with that in mind, let's take a look back at the presentation. So we were looking at what's the difference, right? So we see that the difference in syntax is over here for a for loop, you have your number over here, which is the starting statement, right? And then you have a condition over here, which is your ending statement. And then you have an increment over here, which is your next step statement. But over here, in a while loop, so if I were to take this and turn it into comments, right? Let me do this. Then in this case, this becomes your starting statement over here. Your ending statement becomes this over here. And then your next step statement. I wonder what's going on there. That's strange. I'll fix it later. Your next step statement goes over here. Why is there an equal sign? Okay, there. So that is pretty much the difference between them. You just put things in separate spots, but a for loop can turn into a while loop very easily. So that's pretty much what the case is here.
But remember, a while loop cannot be turned into a for loop. So why is that? So there is one case that can be shown right away is when you use a explicitly a Boolean value. So let's say, can you do Boolean done equal false?
Okay.
All right, and then write a while loop for it.
Okay, so while we're not done, we're going to do something inside of the while loop.
And then let's say done is true.
Just done equals true. Like that?
And let's print out the value. Done.
Before or after?
This should be after.
Okay.
Because I want the value true, not false.
So
in this case, huh?
Go ahead, you first.
So in this case, when you start with Boolean done equal false, you go into the while loop. So the opposite of false is true. So while is true, it will run, right? So it enters the loop. Now done is set to true. You print true right here, and then you go back. So the opposite of true is false. So now while false. So it's false, right? It cannot go into the loop anymore. So you stop. So the value you expect done to be print is true. So go ahead and print it.
Okay. So let's go ahead and print it. So it should print true, which is exactly what as you said. So go ahead.
Okay. But then you cannot convert this while loop into a for loop, because remember, when you initialize a for loop, there are three parts for it to be working, right? And remember, the third part is I++. In this case, like not be equal to true in the last part. So the condition, the three statements here are never like really complete. And so it's not really working when you convert a while loop to a for loop in this case. Do you have anything to add more?
Yeah. So here's the thing, right? So it's as she said, it works mechanically different. And the reason being is over here, the starting statement for this loop, it's a number, right? And then for a for loop, you have to put a number here. You have to say int something equals 0. And it works just the same over here. But for this while loop, we're using a Boolean, not a number. So how are we supposed to stuff a Boolean over here? We can't just say like put a Boolean there and then it compiles. Java's going to tell you, no, that's not what you're supposed to do. That's wrong. So you can go from a for loop to a while loop, but you can't always go from a while loop back to a for loop. There's just too many special cases. And then some people might ask like, oh, well, when do we ever actually use this? Like we say done equals false, right? And then we say while we're not done, do something, right? So the way it goes is, this is actually a very common algorithm, I would say. So you can say something like, if you never know the exact number you're done, and you're always looking for a condition, right? So let's say your code does something here over and over, right? Then you're just going to have an if statement like this, and then you put done equals true, right? So like over here, you would say something like if then there's probably some kind of Boolean here, right? Like if something happens and actually, if something happens that says we're done, then we set done is equal to true. So that's the idea behind it. And this is actually a really useful algorithm that I use quite a lot for even some of my older classes, not older, newer classes. So yeah.
And this sequence of code works really well if you're trying to find matches.
So for our exercise today, and I do encourage that everyone starts it ahead of time and tries it on their own, but Yen and I are also going to do it. We're going to be using a class. We're going to call it second A finder, and we're not actually going to write like a constructor or anything like that. We're just going to do everything in public static void main string args. So we're just going to do everything in the main method. So I prepared an empty class over here ahead of time. So I wrote out some comments just to make it easier for myself to understand as well. So the first thing you should do is second A finder is supposed to ask the user to give a phrase that holds at least two A's. And the user can be wrong. They can be wrong. They can say like apple, which only has one A. Then they'll be like, okay, that's wrong. But if they say something like, what's something with two A's? Apache or something. Yeah, sure, Apache. Then the program will say, okay, your second A is located at wherever that index is. So for example, if it was Apache, right? So I'll write in the code for now for Apache. So if it was Apache, then the indexes would be 0, 1, 2, 3, 4, 5, 6. Then the result should bring me back the second A is at index 3. That's what it should say. And if there's not enough A's, so if there's only one A or less, then the program is going to say, sorry, there's not enough A's. Yeah, so just like that. And the idea is to make a loop that doesn't go through the entire string. Like as soon as you get to that second A, you stop right away. You stop immediately, and then you return the result afterwards. So go ahead and you guys can go ahead and try that on your own. But Yen and I are going to do it this side. So if you get stuck, just look at what we're doing, and maybe you'll get a hint. Okay. So let's go ahead and start it. Okay. So and also don't forget about questions in the chat. You're free to ask questions whenever you want. Okay. So let's start. So Yen, whenever we're doing an activity like this and it says it will ask the user for a phrase, what does that usually mean?
That usually that user will have to enter an input and they expect an output from you, right? So that would be some class that we already cover, which is scanner. So the first, and in order to use scanner, a predefined class, you have to import java.util.scanner. And then in your main method, you would initialize a scanner object so that you can use scanner methods. New scanner. New scanner.
Oh, right. I'm so used to Swift.
And now, now that you have your scanner object, you would ask the from, which is system.out.print, please enter a phrase or something like that.
Say something that has 2 A's.
All right, and this output will be shown, and the user will know what to enter, right? So now, since they're gonna enter something, right? You want to store that. So now, since we're looking for a phrase, string would be the data type that we want to store. So string something.
Okay. So string str equals
scan.next line.
So this is where some students like to use next. Is that a good idea, Yen?
So notice that there is a difference between .next and .next line. .next is on when you look for the nearest word. And then we remove for any space in between just one word. But for next line, it consumes all the words within the string. So say you enter an apple, unspace apple, right? Then unspace apple will be your phrase stored in when using next line string. But when you do n space apple using .next, only an will be stored to your string. So that is the difference. So in this case, when we want more than one word, we will use next line. So that we have everything we need to compare later on.
So we're going to use next line.
Yeah. So now that we have our string, let's look at the next instruction.
Let me actually bring this over here because this is where it's supposed to go. So it starts the phrase. All right, so the next part. So we stored the phrase, and the next part is to actually check that phrase, right? So whenever we want to look at a string again, what's usually the go-to?
So I'm not sure what your question means, but I would play it safe. So the user can enter any input with any letters, including lowercase or uppercase. So to play it safe, I always put scan dot next line dot to lowercase.
Okay, that's what you meant.
C had to be capitalized, I think. And because you can call to lowercase, because let's look, scan dot next line will return a string for you, right? And now you enter string class, and using method from string, which is to lowercase, it will work in this case.
So I know some students get confused when they see this right here, when you do two methods back to back. So Yen, is it doing the same thing as this?
Yes.
And then just using that.
Yeah, that would be a long way if you don't really understand why we can use two methods in one line. The other way is the shortcut where you can use a combine. This works because dot next line and dot to lowercase are both accessor methods. So they just gonna return the values. They don't really change anything in between. So that's why it works in this case.
All right. So yeah, guys, that's when you see dot something and then dot something again, and there's parentheses over here, that just means you're using methods in combination in one line. Just so everybody knows that. Okay.
All right.
And yeah, so we do this to make sure we take into account capitalizations and whatnot as well. Okay. So now it's the next part where we actually have to check the phrase, right? Like we have to look at the string itself.
All
so from class, you guys were given a loop that looks through a string, one letter at a time. And it looks like something like this. So normally you do it with a for loop, right? I'm just going to show them real quick, yeah. So normally you do it with a for loop, and you would say string dot length, I think, and I think it was a method. So, and then you would use string letter equals string dot substring I and I plus 1. Now, is this what we want here, Yen?
So in this case, so the question for this one is asking to find the second match. So recall that when we did the difference between while and for loop, we used the Boolean to find the first match. For this one, if we use the for loop, it will run throughout the whole string. And this is not what we want for this question. We want to stop right away when we found the second A. But this for loop will go no matter what until the end of the string. So it will give us the actual wrong data if it actually works. So in this case, a for loop is not the to-go one for this one.
Yeah. And for those of you guys who say like, okay, well, I mean, they could both work. but why would we want to do it that way where it stops at the second A right away? Well, imagine if you had a string that is so long, it takes 2 hours to go through all of it. And then the second A is actually like the 10th letter. Then obviously you want it to stop right away, right? So it's just good practice to think of performance in terms of that. So you want to use code that that ends as fast as possible. So for that reason, we're going to be using a while loop. So so before we even use the while loop, let me just put this here. I'm just going to put true so it compiles. Okay, so before we even use the while loop, what tools do you think we need, Yen?
So again, for while loop, we need an initial value. So since we don't have it, and since we cannot put it inside a condition, we have to initialize a value first to count the number of iteration. So let's say, so since we're looking for position, we need an initial position. And with string, the index always start with 0. So let's say in position pos equal, or index equals 0. And then since we're also looking for the first match, we need some type of Boolean value, right? So let's do another one. Boolean done equals,
I think it was lowercase.
false. All right. And also there's one more thing in this one, is not the first match, the second match. So we need some kind of counter to keep track of the match number. So if it matched the first time, yes, increment 1. If it match again, yes, increment again. So then if it's true, then we know it's true. All right. So now I think that those are the values that we need. So let's go ahead and go into the while conditions.
Okay. Yeah. So this, as you guys can see, this is kind of like a combination of first match and counting matches, because you want to end right away at the second match, but you got to know when it's the second match. So you kind of use a combination of the two to get this problem really working. So in this case, what should be our while condition yet? So we have. Right. So okay, well, yeah, go ahead.
So since it's finding the first match, we want to utilize the Boolean value done. So while not done, which is going to return to true, right? So you can run your while loop. And then you want to, so if it doesn't find a first match, it's okay. You also want the index to be less than the length of a string. So n index less than string dot length. Right.
So some students are actually confused by this. They're like, okay, don't you just need this? Why do we still need this?
So for this one, not so okay. So if you don't have index less than string dot length, then the letter never moves to the next one if you do the test condition inside. So if it's not having comparison with different letter every time, then your not done will always be true. And this would give you so you can never set it to true in the loop. And when you go out, it will be like not done again, which is true. Then this while loop will always run. And so it would give you an infinite loop. and that's not what you want in this case.
So there's two things to look out for in this case, guys. So as I mentioned before, it's a combination of counting matches and a combination of what was the other one? The first match.
Counter. Yeah.
Counting matches and first match. So here's the thing. With first match, you have to use this right here, right? So you want it to finish right away. And over here, for counting matches, you want to make sure you don't go out of bounds in this string. So there's two ways to really finish this algorithm. You either find the second A. So that's what this one is for, when you find the second A. And that's the second way of finishing the loop is to go to the end of the string. So either you end up at the end of the string and then there's not a second A, or you end up at the second A. So then that's why we need both of these conditions.
All right. So now that we have a condition, let's move on to the statements inside the while loop. So the first thing we look, in order to compare anything, right, we need to get the current letter of the string. So let's initialize and declare and initialize a current letter.
All right, so then string current letter equals string dot substring, and then most of the time when we're using a for loop, we're using I, and we would say I and I plus 1.
Mm-hmm.
But in this case, guys, it's different. We're actually using index instead of I. So watch out for that.
All right. And now that we have a current letter, let's move on to our test case. So let's do some comparison. So when you have comparison, you use the tool that we already learned, which is if statement. So if current letter, and when compare strings, you want to use dot equals. So dot equals parenthesis and a quotation. So consistent again. So remember that when I have when we have string dot equals scan dot next line dot to lowercase, all the input will turn to lowercase. So when you do your comparison, remember your quotation inside this letter right here should be lowercase, not uppercase A.
Mm-hmm. Question: if they use this instead, where they go uppercase, then does that mean they just change it to this?
Yes. So consistency, uppercase, uppercase, lowercase, lowercase.
Okay.
All right. So if the current letter is actually equals to A, then we want to update the number of counts, right? So let's say count plus plus. All right, so that is done for that one.
Mm-hmm.
But there is also one more catch. You want to make sure that the count is actually equal to 2, because that is the second match, right? So how do we do that, Mark?
Okay. So we have the while loop checking if it's ever A, and then we count up every time we say it's A. But what do we have to do immediately after we count up? Well, we have to check if it's the second A, right? And the way to do that is we look at count itself. So we'd have to make another if statement. But what are we checking? Again, we're checking if it's the second A. And when is it the second A? It's when count is equal to 2. Now, what do we do if count is equal to 2?
So if count is equal to true, then you want to set done equal true. because now that you found your second A, what's the point of going on more, right? You can end there. That is your task. Then, but this is done for the if loop. I mean if statement. So let's move out of the if statement. But then there's also one more thing that you should do before you exit the loop. So what is that, Mark?
Okay. So whenever it comes to these loops, we have to make sure we go on to the next step. So if I looked before to my older code, oh, it's right here. Okay. Oh wait, it's right here. Okay. So we always had to have a next step statement after we had the code to repeat over and over, right? So I'll just put this over here just for clarity. So we have that code to repeat, and then we had to use the next step statement. In this case, we're missing that. And over here, we have to increment something up, right? And in this case, it would be index, because we need to know what's the next letter, right? And that's how we move up the index, up the string. So we have to count the index up. So that's the only way we can make it progress.
All right. And now you wanna test if your code is right. So outside of the while loop, the next instruction is to see if you found any A's by the end of the string. So this would be another test case. So let's say if done, then then you will print out the index of the second A that you found.
Second A is at index, and then you add, so then we use string concatenation here, which is index. And that's how we would say this.
Index -1.
Yeah, so some students will be confused here. Why do we say -1 yet?
All right, so you had two parentheses, yeah. So why do we put index -1 instead of index? Okay, so let's trace. Let's say we enter an apple, right? So when you go to the second A, so 0, 1, 2, 1, 0, 1, 2, 3. So it's 3, right? Mm-hmm. So when, let's say, you go to the current letter, it gives you the index. Oh, 3 to 4. That will give you the second A. And then you go here is true, so I counted 2. Cow is 2, then now it's true. But then look at the last line. It's that index plus plus. So now your 3 is 4, right? But then you go back to the while loop. Your condition is not true anymore, because now done is true and not done is false. So you stop there. But your index is 4. But the one that you found is actually at 3. So when you print out your statement right here, you want to minus that 1 that you add at the end of the loop to get your actual result. Okay. Do you have anything to add, Mark?
I mean, so that's pretty much it. It's just because with the way this while loop is structured, we're always using index plus plus, even after we find the this statement right here.
Right.
Now, I know there's another way to fix this so that we don't have to use index -1, but it's not something you would learn in this class. So we're just going to go with it as it is. So we have to offset the 1. So we subtract by 1 to compensate the offset.
And then the next one will be the else. So then we will print some message. There is not enough A's in your string, something like that.
So there's a student in the chat who mentioned, can we just say index minus minus in here? And would that fix the problem with using this? And
I think
go ahead.
I think that would work as well. But then, yes, I think that will work as well. Because you compensate that at the second if. So I think that will work. What do you think, Mark?
Give me a second. Okay. So I think it would work. I would have to try it. We'll try it after this, but it should offset it for you, so you don't have to do this minus one over here. So it's kind of like saying just do minus one right over here instead. So we still, like, whether you want to subtract one over here or over here, it's really up to you. It's pretty much the same thing when you kind of think about it. But another student is arguing, okay, well, that the argument here is if we add that extra line, then that's an extra line of code. Isn't it nicer to just have it over here in this one line? Well, that's true. It does make the code shorter, but it does make the code more readable at the same time, right? Like, oh, we're printing index, not index minus one. So it's kind of like pros and cons of both. They have their good side and bad side, but first we got to make sure it works, right? We'll try it after this just to see what happens, and I think we're ready to test it out again.
Mm-hmm.
Okay, so let's try it. So let's say the word was Apache, right? So whenever you want to test your code, obviously you want to like test it yourself mentally. So I'm going to say Apache, or Apache, and it's 0, 1, 2, 3, 4, 5, 6. So it should print out 3, right, Yen?
Yeah.
Okay. All right. Sounds good. So I would have to compile it now, and then let's try it. And it does work. It does print it at 3. Now let's try it with something that doesn't have 2 A's. So I can say A's, D, W. Okay, so sorry, there's not enough A's. Okay, now let's try it with no A's. So not even a single A. W, W, W. Yeah, so it seems to work just fine.
Let's try the method where there is index minus minus inside the next second if statement.
Okay, so we take out this minus 1, and then we put index minus minus. So let's see if that works. Let me put it here, try it. So Hachi. And it does work. So that pretty much confirms it for you. And let me just, I like being consistent with my format. So I'm just going to add that period to the end.
So there is number of ways to check if your index is right, or like print out the value of your index. Having index minus minus in there would be good too. Yeah, that is another way that you can think of.
So a very common thing you'll see as you go up the the learning curve of programming is that there's really lots of solutions to these things, and you're just going to notice that there's some ways that are faster than others, and that's actually where it counts. You'll learn that into 46B, but we're in 46A, so we don't have to worry about that too much. The point is, you just want to find one of these solutions, not the best one. But that's good. It's good that you're thinking ahead of the class. So is that everything for this activity? Yeah?
I think so.
Okay.